Good morning. We are going to solve one question based on this theorem, Theorem 1.3. Let P be the prime number, P divides A square, then P divides A, whereas A is a positive integer. So, if 2 divides 64, that is 8 square, then 2 divides 8 also. Okay, 2 is a prime number and 2 divides 64, that means 2 divide 8 square implies 2 divides 8 also. 3 divides 81, that is 9 square, implies 3 divides 9 also. 3 is a prime number and 3 divides 81, that is 9 square, that means 3 also divides 9 also. This theorem says like this. So we are going to solve one question based on this theorem. Okay, so this is the question. Prove that root 2 is irrational number. We solve this question by method of contradiction. So we take root 2 is a rational number. Okay, we are going to prove irrational number, but let we take root 2 be a rational number and apply all the property of the rational number. If all the properties not match with the rational number, then we say that this number is not rational. So obviously if the number is not rational, it's obviously irrational number. Okay, so let we take root 2 be rational number. We know that rational number means the number which in the form of p by q, p and q are integers, q not equal to 0, and p and q are co-prime. Co-prime means the number which are having only one as a common factor. P and q does not have any common factor other than 1. P and q also co-prime. Okay, rational number means what? P and q are integers, q not equal to 0, p and q are co-prime. Rational number come in this form, p by q. Okay, so we take here, let root 2 be a rational. That means what? Root 2 come in the form of p by q. Okay, so we write, so root 2 comes in the form of what? A by b. Okay, a by b, p by q, like this. We take a by b. Okay, let we take root to be rational number, so we write root to be a by b, whereas a and b are what? B are co-prime. That means a and b having only one as a common factor. Okay, none other number which are common between a and b. Clear? So root 2 equal to a by b. Okay, so we multiply, cross multiple. Root 2 b equal to a. Okay, then squaring both sides, what do we get? Squaring squaring both sides, we get root 2b square equal to a square. Okay, then this we write 2b square because root 2 square is 2 only, a square. We take this be some equation number 1. Okay, squaring both sides, then we apply the square here, and then we get 2b square equal to a square. So we see the relation, we get like this, 2b square equal to a square. Okay, that means whatever number present here, this 2b square is some number. That means 2 is a common factor of that number, which is equal to a square. Okay, suppose I am taking a square be 18. That means what? This will write like this, 2 into 9. That means what? 2 divide this. If a square is 64, that means this side, left hand side, is 2 into 32. Okay, when you see this relation, 2 obviously divides 64. 64 is obviously divisible by 2. Okay, if this is 16, this side is written as 2 into 8. Okay, obviously a square is 4 square, and this is b square is root 8 square. This 2. This is the relation. When you get this type of relations, we obviously tell that 2 divides a square. Now we write from this relation 2 divides a square implies what? Implies 2 also divides a. So we take from that theorem. Okay, this theorem we take from this theorem, p divides a square, then p divides a. Okay, obviously 2 is a what? 2 is a prime number. 2 divides a square, then 2 divides a. So we don't know the value of a, but we know that the value of a is divisible by 2. So we take the value of a. Let a equal to 2c. Okay, let a equal to 2c. Let a equal to 2c because a is a value which is divisible by 2. So we take a value of a which is equal to 2c. Okay, now putting the value of a, putting the value of a in equation 1. Okay, we get what? We get 2b square equal to 2c square. Okay, implies 2b square, we get 4c square. Cancel it down. What we get? B square equal to 2c square. Now you see the relation, b square equal to a square, b square equal to 2c square. Okay, 2b square equal to a square, b square equal to 2c. That means this condition is again repeated. We tell that 2 divides b square implies 2 divides b also. So we see that 2 is a number which divides A and B also, A as well as B. You see this relation? 2 divides A and 2 divides B. That means 2 is the common factor of both A and B. So what you take at the beginning? A and B are co-prime. A and B are co-prime. That means A and B has only one as a common factor. But we see this 2 is also the common factor. So what we take earlier, this is not correct. Okay. So 2 is what? Therefore 2 is common factor. Common factor of both A and B. A and B. So which is not possible, because for rational number we have A and B co-prime, but we take 2 is the common factor. 2 is what? Other than 1. So what we take? Let root 2 be a rational number, which is not correct. If this is not correct, then we call 2 is irrational number. So our assumption is not correct. So our assumption is not correct. Therefore, root 2 is not rational number. Not rational number implies root 2 is irrational number. Irrational number. Okay. In this way we prove this root 2 is a irrational number. Okay. Once again you see this. So this is our question. Proof that root 2 is irrational number. So in solution, what you take? Root 2 be a rational number. We prove this by the method of contradictions. Okay. So root 2 is a rational number. If this is a rational number, so root 2 come in the form of P by Q. So we take A and B. Okay. A, B is some positive integers. Okay. Whereas A and B be co-prime. Rational number, then A and B must be a co-prime. Co-prime means the number which have only one as a common factor. Okay. The same we will write here. Okay. Then cross multiple, this B will go here. Then squaring both sides, we got like this: root 2b whole square a square. After squaring we get 2b square equal to a square, because square root 2 is 2 only. Okay. So we get a relations. From this relation we get 2 divides a square, that means 2 divides a. Now we write this from the theorem, above theorem. Okay, we discussed earlier. Let we take a equal to 2c. Okay, we assume the value of a equal to 2c because we don't know the value of a, but we know that a is a value which is divisible by 2. That's why we take let a equal to 2c. Putting the value of a in equation number 1. After solution we get like this: b square equal to 2c square. Okay, so same relation we set up as equation number 1 here. Okay, one this. Okay, so 2 divides b square, that means 2 divides b also. So from this two relation, this 2, we get 2 is a common factor of both a and b, but we take a and b are what? Co-prime. Co-prime means only one is a common factor, but we get 2 is also common factor. So what you assume? Our assumption is not correct. If our assumption is not correct, we tell root 2 is not a rational number. That means root 2 is a irrational number. Okay, this is the proof, and all the proof like root 2 is a irrational number, root 3 is a irrational number, root 5 is a irrational number, root 11 is irrational number, 13 is irrational number. All the irrational number root over are proof in this same way. Okay, so you see this question properly. Thank you for today. And you try the other value of root like root 3, root 5, root 7, root 11, 13, all value. At least you try 4-5 question same like this. Okay, thank you.